basic solution is, suppose you have m constraints. Suppose you have m constraints and n variables. Suppose you have m constraints and n variables. Calculate n minus m. Calculate n minus m. If n minus m is equal to whatever value you get, that many variables you have to put 0 and solve for the remaining variables. I'll show the example there in the next slide. So that is called as a basic solution. Okay, a solution obtained by setting any n variables out of n plus n. If there are m constraints and n variables, calculate n minus m. If n minus m equal to 1, then put one variable equal to 0, solve for remaining 2. Then those two variables will be called as the basic variables, or the solution will be called as the basic solution. I will explain this part in the next slide with the help of an example. Whatever solution you get, basic solution, if it satisfies the last condition that all the variables are greater than or equal to 0, it is called as basic feasible solution. And if any one of the solution becomes 0, it is said to be a degenerate basic feasible solution. And if all the basic variables are non-zero, it is said to be non-degenerate. So first, our aim will be to get the basic variable or the basic solution. If all the variables satisfies this non-negativity restrictions, we say that it is a basic feasible solution. If this basic solution, if any one of these basic solutions are 0, it is said to be a degenerate basic solution. And if it is non-zero, it is said to be a non-degenerate. Okay. So degenerate matlab one of the solution is equal to 0. Non-degenerate matlab all the solutions are not equal to 0. Feasible matlab all the solutions are positive. अगर पॉजिटिव है, सब सॉल्यूशंस की वैल्यूज पॉजिटिव हैं, तो इट इज अ फिजिबल सॉल्यूशन. उसमें से कोई भी एक अगर 0 है, तो इट इज अ डिजेनरेट सॉल्यूशन. एंड इफ ऑल आर नॉट इक्वल टू 0 एंड पॉजिटिव, इट इज सेड टू बी अ नॉन डिजेनरेट. So just do one problem. These problems are normally expected under the compulsory part, previous slide. Okay. This explanation I will explain when I do the problem. You will understand it clearly. Feasible मतलब नॉन नेगेटिविटी, डीजेनरेट मतलब अगर 0 है तो, एंड नॉन डीजेनरेट मतलब नॉन 0. एनी डाउट? Once it is done, please let me know so that I can move to the next slide. Done, Darshana? Determine all basic solutions to the following LPP. Also identify the solutions which are degenerate, feasible, and optimal solutions. This is the first method of solving x1, x2, x3. Okay. Now, यहाँ पे see how many variables are given in this problem. x1, x2, x3. There are 3 variables given. Okay. How many constraints? How many constraints? How many constraints are given in the problem? In this problem, the first problem. No, it is not 3. This part is not called as constraint. This is a non-negativity constraint. Only these are the 2 constraints. The last one is not called as the constraint, it's called as non-negativity constraint. These 2 are only constraints. Okay? This is called as a non-negativity constraint. So we have only 2 constraints. So number of constraints we denote it by m, which is equal to 2. And the number of variables are x1, x2, x3. So we have n is equal to 3. M is equal to 2, n is equal to 3. Putting n minus m, that is 3 minus 2 equal to 1, we have to put one variable equal to 0. So check the number of constraints, number of variables, denote the number of constraints by m, number of variables by n, calculate n minus m. If n minus m, whatever answer you're getting, that many variables we have to put it equal to 0. Here we get n minus 1 equal to 1. So put one variable equal to 0. There are 3 variables, put one variable equal to 0. Suppose I take x1 equal to 0 from these 2. अगर x1 0 है तो what are the remaining equations we get? 2x2 plus 3x3 equal to 4, 3x2 plus 5x3 equal to 7. Solve these 2 equations using calci and tell me the values of x2 and x3. We have to put one, there will be 3 cases. We have to put one variable and then solve for the remaining variables depending upon this number. अगर यहाँ पे 2 आ रहा है तो we have to put 2 variables equal to 0. तो यहाँ पे 1 आया है तो वी हैव टू पुट वन वेरिएबल. तो सबसे पहले मैंने x1 को 0 पुट कर दिया. तो once I put x1 equal to 0, we have only 2 equations, 2x2 plus 3x3 equal to 4 and 3x2 plus 5x3 equal to 7. Solve these 2 equations simultaneously and get the values of x2 and x3. So what are the values of x2 and x3? Solve using calci. 2x2 plus 3x3 equal to 4 and 3x2 plus 5x3 equal to 7. Minus 1 comma 2. Okay. Rishikesh is also saying minus 1 comma 2. Okay. Let me check my answer. Minus 1 comma 2. Now we have to write what type of solution is this. Is it a degenerate? Degenerate का मतलब होता है कोई भी वैल्यू अगर 0 आती है, it is called as degenerate. Okay. तो यहाँ पे this is not degenerate because we are not having any of the solutions to be equal to 0. What about feasible? Feasible means all the variables should be greater than or equal to 0. But here we have one number which is less than. So it is not feasible. So I will say the solution is non-degenerate, not feasible, non-feasible. कोई भी solution 0 नहीं है, so it is non-degenerate. Okay, none of these, now these x2 and x3 are called as the basic variable and x1 is called as a non-basic variable. x2 and x3 are called as the basic variable and x2 and x3 are called as the, x2, x3 is a basic variable, x1 is called as the non-basic variable. So since none of the values are equal to 0, the solution is non-degenerate. And since one of the variable is minus 1, it is not a feasible solution. We say it's a non-feasible solution. Or agar feasible nahi hai, तो we cannot calculate the optimal also. feasible होना चाहिए, तभी we can calculate we can substitute or calculate the value of z. ये पहला केस हो गया. सेकेंड केस में पुट x2 इक्वल टू 0. तो पहले केस में x1 इज अ नॉन बेसिक वेरिएबल, x2 x3 इज अ बेसिक वेरिएबल. ठीक है ना. सेकेंड केस में x2 को 0 पुट करेंगे, सॉल्विंग फॉर x1 एंड x3. इन द सेकेंड केस, case 2, put x2 equal to 0. When x2 is 0, I will get x1 and x3 equations. x1 plus 3x3 equal to 4 and 2x1 plus 5x3 equal to 7. Solve for x1 and x3. जितना भी n minus m आता है उतने वेरिएबल्स को हमें 0 पुट करना है और सॉल्विंग फॉर द रिमेनिंग वेरिएबल्स. So x1 plus 3x3 equal to 4 and 2x1 plus 5x3 equal to 7. Again, tell me the values of x1 and x3. Solving for x1 and x3. 1 and 1. Okay. x1 equal to 1, x3 equal to 1. What type of solution is this? Is it a degenerate solution? डीजेनरेट मतलब जो भी वैल्यूज हमारी आई हैं उसमें से अगर 0 आ रहा है तो इट बिकम्स अ डीजेनरेट. None of the variables we are getting the answer as 0, so we have non-degenerate, and none of these variables are negative also, so I will say that the solution is non-degenerate and feasible. Why it is feasible? Because none of the variables are having a negative sign. So it is non-degenerate मतलब zero भी नहीं है. Zero है तो degenerate and feasible हो जाता है. अगर if it is not zero, then it becomes a non-degenerate and feasible solution. So in the second case, x2 will be a non-basic variable, x1 and x3 will be a basic variable. And once you get a feasible solution, calculate the value of z. Calculate the value of z. तो कितना हो जाएगा? Z will be equal to x1 is 1, x2 is 0 and x3 is 1. So we will get 1 plus 3, that is equal to 4. That is equal to 4. ठीक है? The second case. Similarly, we can write the third case. Third case will be putting x3 equal to 0. Okay? Putting x3 equal to 0. When I put x3 equal to 0 in these two equations, we have to solve for x1 and x2. So I'm repeating again, you have to see how many constraints and how many variables. Name the constraint as m, variables as n. Put n minus m equal to 0, see what is the answer you get, and accordingly you have to write the, that many variables are to be put equal to 0. So what are the answers? 2, 1, okay. So x1 is equal to 2, x2 is equal to 1. What type of solution? What types of solution we get here now? 2 and 1. Is it a degenerate solution? Is it a degenerate solution? Yes or no? No. Why it is no? Because none of these values are equal. This is equal to 0 because it's a non-basic variable. अगर basic variable में 0 आया तो it becomes a degenerate solution. It is non-degenerate and feasible solution. Now once you get a feasible solution, calculate the value of z here. So z is equal to x1 को 2 put करना है, x2 को 1 put करना है and x3 को 0 put करना है. So we will get the answer as 5. Z is equal to 5. So there are only two solutions. Case 1 में we got not feasible, so that is not a solution. We have only two solutions. One solution is x1 equal to 1, x3 equal to 1, z equal to 4, and second case is x1 equal to 2, x2 equal to 2, and z is equal to 5. So what is the problem? It is maximize z. जो problem है यहाँ पे maximum z है. तो z की value कौन से इसमें maximum है? In the case of third, in the third case, z is maximum in the third case. So this will become the final solution. The solution will be, optimal solution will be x1 equal to 2, x2 equal to 1, and z is equal to 5. ठीक है? Only in two cases we are having the z value because we have feasible solution. Only if it is feasible, if it is degenerate also it's okay. But if it is feasible, then only you have to calculate the value of z and see whichever z, if it is asked maximization, see for maximum z. If it is given minimization, then check for the minimum z. So whichever is the maximization z here, that is corresponding to this 5, and this 5 is corresponding to x1 equal to 2, x2 equal to 1. So this becomes our optimal solution. जहाँ पे मैक्सिमम, अगर हम x1 को 2 पुट करेंगे, x2 को 1 पुट करेंगे, तो we will get an optimal solution as z equal to 5. ठीक है? So this was, so this whatever variable we are put, that is why the definition was like that. By setting m variable, by if you have m constraints and n variables, and by putting n minus m variables equal to 0, solving for the remaining variables, the solution obtained is called as a basic solution. So this is a basic solution. This is a basic solution. Let's take one more. Maximize z equal to 2x1 plus 3x2 plus 4x3 plus 7x4 subject to. It's a simple problem here. Only you have to solve the equations, get the values of the variables, and decide whether it is a degenerate or feasible or optimal, etc. Two x1 plus 3x2 plus x3 plus 4x4 equal to 8, x1 minus 2x2 plus 6x3 minus 7x4 equal to minus 3. All the variables are greater than or equal to 0. It's already there in the standard form. Even though we need not convert here because it's already equal to sign. Okay, now how many constraints? What is the value of m?
2.
Huh? M is equal to 2 because the number of constraints. What is the value of n? N की value क्या है?
4.
4 because there are 4 constraints. Yes, 1, 2, 3, x1, x2, x3, x4. And n is equal to 4. So what is n minus m? It's 4 minus 2, which is equal to 2. So now you have to put two variables. Don't treat this as a constraint. Okay, only these are the two constraints we have. So now, since we're getting the answer as 2, put two variables equal to 0. Put two variables equal to 0. So you have to have all the possible combinations. Okay, so we have to have all the possible combinations. So case 1 will be, so what I will do is I will start with x1. पहले मैं x1 x2 का कॉम्बिनेशन लूंगी, फिर x1 x3 का कॉम्बिनेशन लूंगी, फिर x1 x4 का लूंगी, उसके बाद x2 x3 x2 x4 and then x3 x4. Okay, depend. I'll go in the order so that not no cases are missed. So putting x1 equal to 0, x2 equal to 0. अगर दो variables को हमने 0 put किया तो what is remaining now? x3 plus 4x4 equal to 8, 6x3 minus 7x4 equal to minus 3. Calculate the values of, solve these two equations and get the values of x3 and x4. Solving these two equations and getting the values of x3 and x4. (14), 1.419, 1.645. Okay. Both positive. 44. Yes, even I have it in fraction. That's fine. Anyway, you can write 44 by 31, 51 by 31. Yes, also, I also have got. So it's okay. Even if you write the answer in decimals, nothing wrong. But I have written the answer in terms of the fraction. What type of solution? What type of solution? I think it's same, na? 44 by 31 is same as 1.419. And 51 by 31 is 1.645, I think. Okay. What type of solution we get in case 1? Is it degenerate? non-degenerate and feasible. None of the values are equal to 0 and both the values are positive. So we get non-degenerate and feasible. Okay. Once it is feasible, calculate Z. Calculate the value of Z. इसमें Z में क्या करना है हमको, जो भी वेरिएबल्स को हमने 0 पुट किया उसको यहाँ पे 0 पुट करना है, एंड द रिमेनिंग वेरिएबल्स वी सब्स्टिट्यूट द वैल्यूज. सो व्हाट इज द वैल्यू ऑफ Z? What is the value of Z? Either in fractions or in decimals, both will do. Simplify करना है. 4 into 44 by 31 plus 4, it is 7 into ना यहाँ पे. This is 7 actually. आंसर चेक कर लो एक बार. गलत है ना मेरा. 533 by 31. Okay, because I took it as 4, no? 533. Okay. What is in decimals? What do you get? 12 point, is it? 12.25. Okay, that is right, I think, no? 12 point, ठीक है ना? Okay, fine. I got 12.25, whatever is it, 258 approximately. Okay, this is the first case. So I've taken x1 and x2 combination. Next, we will take x1 and x3 combination. Okay, x1 and x3 combination. So case 2 will be x1 and x3 equal to 0. Putting x1, x3 equal to 0, solving for x2 and x4. Solving for x2 and x4. 17 point. किसके पास 17 point है?
533 by 31 के लिए वो वैल्यू है.
Case 1?
Yeah.
Case 1, right?
Yes, ma'am. 12.25 नहीं, 17.
Because I've taken 4, na, that is why. So that is कौन सा problem है? So what is the value? 17 point. Okay. 17 point.
हाय के हाँ अनमा हाय के कोणता पॅन्ट हा वाला देऊ सेंड करू दोन्ही पण सेंड कर.
ठीक है. Second case. Calculating the values of x2 and x4. What are the values of x2 and x4? I got the answer as 44 by 13 and minus 7 by 13. Is it correct? What is 3 point? Minus में आ रहा है. Okay, this value is 3 point. Okay, fine. Is it okay in fraction? 44 by 13 and minus 7 by 13. What type of solution is this? What type of solution is this? Is it feasible? Is it a feasible solution? Yes or no? Is this value correct first? Please check the values and let me know if you're getting the same answers. It's non-degenerate and non-feasible. Correct है values? Okay, fine. The solution is non-degenerate because we are not having any values as 0, and non-feasible because we have negative sign for the x4 variable. Once it is non-feasible, then you need not calculate the value of z. We can go to third case. So third case, I have taken x1, x2 combination, x1, x3 combination, now x1, x4 combination. Putting x1 0, x4 0, solving for the remaining two. 3x2 plus x3 equal to 8 and minus 2x2 plus 3x3 equal to minus 3. Solving for x2 and x3. 2.3, 2.55, 0.35. Okay, and fractions में क्या है? I've got 51 by 20, 7 by, is it same? 51 by 20, 7 by 20. Again, the solution is non-degenerate and feasible. Once it is feasible, you have to calculate the value of z. So calculate z. x1 is 0, x4 is 0. .05. ओके, ठीक है. तो हमारा x1 के साथ सब कॉम्बिनेशंस हो गए. x1 0, x2 0, x1 0, x3 0, x1 0, x4 0. So next we will take x2, x3. x2, x1 is already done in the first case. So now we'll take x2, x3. Again, putting x2, x3 0, we will get 2x1 plus 4x2, 4x4 equal to 8, and x1 minus 7, x4 equal to minus 3. Calculating the values of x1 and x4. So whatever is your n minus m, put that many variables equal to 0 and solve for the remaining. That's it. That is only the procedure. .444. 22 by 9 and 7 by 9. Okay, fine. Yes. Again, it's feasible non-degenerate, so we can write the value of z. x2 and x4. x2 and x3. I think I've written, correct, x1 and x4, correct. चेक कर लो वैल्यू इसकी राइट है कि नहीं. 31 by 3, 10.33. Okay, 31 by 3, 10.33. Next case is 5. x2, x3 हो गया, x2, x4. Just we can complete this part. I'll just show you the answers now. 51 by 11 minus 14 by 11. This is a non-feasible solution, so we need not find the value of z. Then case 6. Now listen here. Suppose you're solving two equations. Okay? Suppose you're solving two equations and Calci is showing math error. Okay? Suppose you're solving two equations and Calci is not able to calculate. It's showing math error, which means that the solution is an unbounded solution. You have infinite number of solutions. Okay? So in that case, so make a note of, I've done that in the next problem. So what is that? If you are solving the two equations using Calci and Calci is showing a math error, which means that the solution is an unbounded solution. Okay, the next problem, I've shown you that. You just go through that. So out of these 6 cases, whichever z is maximum, that is going to be the optimal solution. I think the case 1 only we get the maximum solution. value changes, I guess 17 point something you will get. Okay, so I think I'll stop here. I have done one more problem. You can just go through that. Same way we have to do, we have 4 variables and 2 constraints. We have to put 2 variables equal to 0 and calculating the value. Okay. So that's it for today. See you in the next lecture. Bye. Please write your attendance. Don't forget to write your attendance. Thank you. Thank you.